It's been a while since I've done a live stream. How you guys doing? I don't think anyone is going to be watching this at all. And it's been a while since I've done a live stream, but hey, here goes. Um so today we're going to do this problem. I haven't done competitive programming in a long time, and I want to get back into it. So there was some problems I was going to try to figure out, get them right, and then I should be able to do well in the next contest or something. Now I can't even do some of these contests because they affect my work schedule, so I can't even do it. Some of these contests, but I could like do like a contest afterwards, like do a virtual contest. But anyway, this is gonna be the problem we're gonna do today, and yeah, let's do this. Okay, so we have a game on a Joyboard. The screen contains n+1 slots, numbering from 1 to n+1 from left to right. The n+1 slots are filled with an array of non-negative integers, so a1 to an+1. Chanika, as a player, must assign an+1 with an integer between 0 and m inclusive. Then for each I from n to 1, the value of ai will equal be the remainder of dividing ai plus 1 by the adjacent value on the right, by I. Okay, so ai is going to equal ai plus 1 mod I. Okay. You want it such that every slot is going to be an integer, and we want k distinct values on the screen. How many ways are there for assigning a positive integer into slot n+1? Okay, so this is like a how many ways? Okay, so this is like a combinations questions. Okay. So the following contains the example. So we have n, m, and k. Okay. What does m represent? Does he ever say what m represents? Okay. Oh, okay. So they must assign an+1 with an integer between 0 and n, inclusive. Okay. So okay. Okay. All right. So okay. So this is not. I could already think of a brute force solution, but we need to figure this out from not brute forcing. So let's try that. Let me look up. Oh no, that's not, I don't want to go on Notepad. I want to go on Google SketchUp. I only have 30 minutes because I'm going to go play basketball. So I'm going to try to do a problem every day and see if this actually does improve. I don't think it's like, I don't think doing a problem every day is that bad. Like I feel like I would definitely improve if I do a problem every day. But that's just on me. Okay, let me close these. Where is the... Didn't I have Google SketchUp downloaded? SketchUp? Sketchbook? Okay, so I think the easiest way to do this, if we're just going to brute force, is just to fill up every single combination from the arrays of values of 0 to m, right? So let's see. So we have AM. The AI is going to be filled with non-empty, an array of non-negative integers. Chanika, as a player, must assign an+1 with an integer between 0 and m inclusive. Then for each I from n to 1, the value of ai will be equal to the remainder of dividing ai plus 1 to the value of right by I. Okay. You want it so that every slot is filled with exactly k distinct values. How many valid ways are there for assigning a non-negative integer into slot n+1? Okay, so we have, okay, so hold up. So we have an array of a1, a2, up to an+1, right? That's what they said. And we want to assign an plus 1 the integer between 0 and m inclusive. Okay, then for each I from n plus 1, the value of ai will equal to the remainder of dividing ai plus 1 with the adjacent value to the right by I. In other words, ai is going to equal to ai plus 1 mod by I. So, the one right mod by I. So it will be 1, 2, 3. So this one goes up to... Okay, so the values of this... Okay, so they want to index it from 1, right? Because... Yeah, 1 to... Okay, so... The index of these will be 1 up to n. Okay? So we have to mod it by 1 to n. Value of ai will be... The value of ai will equal to the value of assigning the remainder of ai and ai plus 1. So, hey, what's up? How you doing? I'm doing a problem right now, so, and I only got like 30 minutes because I'm planning on going to play basketball. So this new array, so we're going to have a new array, and it's going to be the value to the right mod by I. So it's the value to the right mod by I. So this new array, let's call it xn. X of I is going to equal to ai mod by I. ai plus 1 mod by I. So that's going to be our new array. So our new array will be like x1 up to xn, and it's going to equal to this value mod by I, this value mod by I, this value mod by I up to n. So the last value of xn will equal to this previous value mod, or no. Wait, okay. This one, this one adjacent, right? The last value, what would it be though? What are you going to mod the last value by? Because the value on the right, there's nothing on the right here though. For each I, the value of ai will be equal to the remainder of dividing ai plus 1, the adjacent value to the right by a. We have a n plus 1 from 1 to n plus 1 on the right. N plus 1 slots. I guess my question is like, what is the last value going to be? In the entire screen. So there's k distinct values in the entire screen. So you want k distinct values. Divided by the value on the right. For each value consists of 3 values. Okay, each of the number... Okay, I think my main question is like, what is the last value? What do they want it to be? So non-negative is a1, the value must assign an plus 1 with an integer between 0 inclusive. Oh! Channica as a player must assign the last value with an integer between 0 and m. Then for each I from n to 1, the value of ai will be the remainder of dividing ai plus 1 to the adjacent value of the right. So this value, okay, so that makes more sense. Okay, so this value is going to be any number from 0 to m. That's what they said, right? And then for each I from n to 1, the value of AI will be the remainder of dividing AI plus 1, adjacency value to the right, by I, modded by I. So this value, so x of this value is going to equal to this value mod by whichever value mod by I, mod by n, mod by n. So what is this last value then? Is x of n just going to equal to an plus 1? Okay, so yeah, so this value x of n is going to equal to a number between 0 and m, and then x of n minus 1 is going to equal to yeah, okay, so this, okay, maybe I shouldn't use n here. This is n. This value is going to be the value, and then this value is going to equal to the value on the right mod by whichever value this is. So then this mod by this is going to equal to what value mod by this. And then this value is going to be this value mod by I. Okay, so the second value here will be 2, 3, 4, 5 up to, and then the starting value will not get something mod by I. So this value, the first value xn is going to equal to ai plus 1 mod by I, which is 2. So 1 would be a2 mod by 1. Okay, that makes sense. And this one would just be any number between 0 and m. And then, yeah, okay. And they want us k distinct integers, right? For each I from n to 1, the value of ai will be the remainder of dividing ai plus 1 to the value of right. So they want k distinct values in the entire screen. How many different valid ways are there for assigning a non-negative integer into the slot of n plus 1? How many valid ways are there? So how many valid ways are there for assigning a non-negative integer in a slot n plus 1? So they're asking the how many different ways are there for assigning a non-negative integer to this last value so that we get k distinct integers. So you could loop the last value from 0 to m inclusive, right? And then you could fill up the rest of these values to equal what it's equal to. So yeah, and then you could count how many. But I think it will get TLE for that. So what we could do is if we want to get k distinct integers, right? We have to see how many different types of values are divisible by k. So what are the other values? What are they? Why do I have this here? What are the other values are? Can I put n plus 1 slots are to be filled with an array of non-negative integers a1, a2, a3 up to an plus 1. Oh, okay. Okay. So we could just loop through. I think we could just fill the last value with loop for the last value from 0 to m and then fill up the rest of the values and see what that gives us. And then if there are k distinct values in the entire screen, then among all n plus 1 slots, we count x plus plus. So that'll be a brute force way. So let's actually try that, because like I feel like that could still get something, and then we could like boggle down like why it's not working. So Microsoft not Microsoft Edge. I have a Visual Studio, yeah. I'm gonna get a new laptop probably, Because this laptop is like really bad. And yeah, I need a new laptop. But yeah. I'm not sure what I'll get though. We'll see. How you doing, Junior? Ravi? Okay, so last value we're gonna loop from yeah. Okay, so then we're gonna fill up the remaining values of the array. If it equals okay, then we x plus plus, okay? So what is M and K? We have T. All right, I think the face cam is a little, like slowing down my computer process, so I'm gonna actually take this out. But yeah, we'll see if that speeds things up because I can't get Visual Studio load. You guys could see my screen, right? Why is it not responding? Visual Studio. Okay. Let's see if we could get this down. Why are you still not responding? Oh, now it responds after when I close it. Oh, isn't that great? Okay. Okay, so what we're gonna do is we're gonna create an array of n plus 1 values, and our last value we're gonna loop 0 to m. This is gonna be our last value. So r of n plus 1 is gonna equal to I. So we're gonna try each of them. Then what we're gonna do is we're going to loop through and set the other values to equal to it. So we're gonna set from n to 1. So this last value n plus 1 is going to equal to our loop from 0 to m, and then anything less than that, let's say the values of n down to 1, we're going to set that equal to, yeah, we're going to set it equal to the right value mod by the current value of n, and then we're going to check if it's equal to k. So yeah, so we're going to have a set count, and then we're going to loop from n down to 1, and we're going to set r of j is going to equal to r of n plus 1 of j plus 1 mod by j. Yeah. And then we're going to insert this into the count set. And if the count set is equal to k, so we're going to do insert r of j. Mod by j. Yeah, that's right. And then if it's equal to k, we're going to do a count plus plus. So we're going to do a total count. So if count dot size is equal to k, we're going to do total count plus plus. And then in the end, we're just going to see out total count. Now I should get TLE if I do this properly, but what we want to do is get TLE first. So we want to get to the point where we're trying to optimize it. But yeah, I think this should work. Mod by j. Oh, this should be I plus 2. N plus 2. Because the last value is n plus 1. Yeah. Okay. Yeah. So then we're going to do that. Let's see if this works. For the input, so it should be 2105. And then we could figure out like how to do the counting thing. We could then figure that out. So basically brute force this, and I hope this does work. It should work though. Zero, 0, 10. Why is it 10? 0, 2. Why is it 2? Last value should be 0 to m, and then what is k? If it equals to k, it should be plus plus. How many ways of it? And count. We have to get to the brute force solution first. K distinct values in the entire screen. Yeah, that's right. Oh wait, I need to insert an plus 1. Yeah, I need to insert that value first. I need to insert I into count. So count should equal to I first. And then you could insert the values. Yeah. And then I need to reset R also. So we need to reset R is equal to, oh yeah, I gotta reset this. Oh no, yeah. That's right, yeah. Count gets reset. I plus 1, j plus 1, yeah, that's right. Modded by, that's right, yeah. Yeah, this should work. Let's see. 0, 1, 2, 3, 4, 5. Then there's 3 distinct values, yeah. And then 320. 32020. Let's actually loop from M down, go down to 0 because we don't know. I wanted to say that we're able to find, in the first case, one of the 2 possible ways for n plus 1 equals 6. If she does that, then you should have 3 distinct values, yeah. So this would be good debugging if we do it this way. So let's copy all this stuff. So last value will be 6. One, 2, 3, 4, 5. Yep, 5th value is 6, and then you have 0, 0, 2, 2. 2, 2. 2, 2. 0. 2, 2, and then it should be, the rest should be 0, 0. K? What? Oh, fuck. Okay. Yeah, you can't do this because it's overcounting. If count size is equal to K, then you could do this. Okay. 2105. 2105. Yep, 2105. Okay, so we got the brute force solution. Let's see if we could submit it. If we can't, then let's see if we could optimize it, because I have a feeling we could optimize this, because it's not. Let me remember this for a month. We could definitely optimize this. Wrong answer on test 1. So instead of going through M down to 0, we could do other ways to do this. We have to think about like how many ways are divisible by. So we want 3 ways. So from the numbers from 0 to 6, how many numbers are divisible by the values? Runtime error on 2. I get a runtime error. Oh, technically we don't even need an array. We don't need an array. We could just have a current value. So we could have current values are going to equal to I Yeah, and then we're gonna say curve val is gonna equal to mod by j. We're gonna insert curve val. So yeah, that would optimize that because then we don't need to repeatedly do that. Because it's just like the current value mod by whatever the value is. So I'll get TLE here. Just get TLE. Yep, I knew it. Okay. So how many different ways are divisible by the values to the right in order to get 3 distinct values? Because if it's divisible by it, right, and then we mod it by it, it's just going to be like if it's divisible by it, it's gonna hit 0, right? So okay, so I think this question could be reworded down to how many numbers from 0 to so let's say we have 4, 6, and 3, right? So if we had 4, 6, and 3, okay, so we have so 6 and 3. So m is equal to 6, and we want k values. So we're gonna create 1, 2, 3, 4, 5, 6, right? And we're gonna loop from this value to 0 to 6, and then we're gonna fill up the rest of these values with the values 0 mod by 5, 0 mod by it's 5, right? So there's 5. Okay, it's 5. So 4. Okay, so we n is equal to 4. So we have 5 values. 1, 2, 3, 4, 5. Last value, we're going to loop from 0 to 6. This one, we fill up with whatever values that are divisible by 4, 3, 2, and then we go down to 1, right? 4, 3, 2, 1. So here's what we're checking. We're checking 0 to 6 is 4. Okay. 6 mod by 4. 6, and then that value gets stored here, right? So 6 mod 4, and then we get 6 mod 3, mod 4 mod 3, right? So 6 mod 4 mod 3. Right? And then we have 6 mod 4 mod 2. So 6 mod 4 mod 3 mod 2 is here. And then we have 6 mod 4 mod 3 mod 2 mod 1. And that's here. Right? And then we're checking if how many values are there for distinct to be divisible by k to equal to 3. So how many distinct values can you get if we want it to k equal to 3? So if we want to do that, we need to the 6 mod by 4 is 2, right? So let's look at this. So this last value is 6. 6 mod by 4 is 2. This is 2 mod 3. Then this is 2 mod 3 mod 2. So this goes to 0. This goes to 2. Oh, wait. 0, 1, 2, 3. Oh, no. Wait. Two mod 3 is 2. Oh, wait. My bad. This is 6 mod 4, so this is 2. So this is our 6. This is 2. Then we have, so 6 mod by 4, 6 mod by 3, 6 mod by 4 mod 3. So that's 2 mod 3, which is 2. 6 mod 4 mod 3 mod 2. So this gets to 0. And then once you hit 0, 0 mod 1 is 0. So that's 0. So we have 0, 0, 2, 2, 6. Right? And then we have 0, 0. So how many distinct ways are there for k equal to 3? So how many... I think it's how many numbers that are divisible by... that are not divisible by 6 mod... m mod 4 mod 3 mod 2 mod 1. So how many numbers are not divisible by it? So like... let's see. Let's think. Then we have 5 mod 4, mod 3, mod 2, mod 1. Um, 5 mod 4, mod 3, mod 2, mod 1. What is that? 1. So when does k equal to 3? So let's change this and see what we get. 5 mod 4 mod 3 mod 2 mod 1. What does that equal? 5 mod 4 is 1. 1 mod 3 is 1. 1 mod 2 is 1. 1 mod 1 is 0. So we have... so this would be 5. This would be 5 mod 4 is 1. 1 mod 3 is 1. 1 mod 2 is 1. 1 mod 1 is 0. So we have... oh, we have 3 distinct values here. No, we have 2. We have 2 distinct values. Okay, so when we hit something... okay, let's check 4. Set this to 4. 4 mod 4 is 0. 0 mod 3 is 0. 0 mod 2 is 0. 0 mod 1 is 0. So we have only 4. So we have 2 distinct values here. So 4. So that was 2. That was 4. So now we have 1. No, we have 3. So 3 mod 4 is 3. 3 mod 3 is 0. 0 mod 2 is 0. 0 mod 1 is 0. So we have 0. Oh, we have 3 here. So we have... we want 3 distinct values. So we have 0, 3, 0. Okay. Okay, well, let's start over. Okay, so we have 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, so remember 6, right? 6, 5, 4, 3, 2, 1, and we have 0. Okay, so remember this is what we're doing. 3, 3, 3, 3, 2, 2, 2, 2, 1, 1, 1, 1, 0, 0, 0, 0. Okay, so 0 mod by 4 would just be 0, so this would just all be 0. So this definitely can't be it, right? Remember, k is 3. We want 3 distinct values, right? 1 mod by 4 is 1. 1 mod by 3 is 1. 1 mod by 2 is 1. 1 mod by 1 is 0. So this was 2 values. This is 1 value. 2 mod by 4 is 2. 2 mod by 3 is 2. 2 mod by 2 is 0. 0 mod by 1 is 0. So we have 2 distinct values here. 3 mod by 4 is 3. 3 mod by 3 is 0. 0 mod by 2 is 0. 0 mod by 1 is 0. So there's two distinct values. 4 mod by 4 is 0. 0 mod by 3 is 0. 0 mod by 2 is 0. 0 mod 0 0. 5 mod by 4 is 1. 1 mod by 1 mod by 3 is 1. 1 mod by 2 is 1. 1 mod by 1 is 0. Oh, so this is k equal 3. So this is right. This is 2. So this is wrong. 6 mod by 4 is 2. 2 mod by 3 is 2. 2 mod by 2 is 0. 0 mod by 1 is 0. So this is a k equal 3 also. So we have two ways to do it. Both of these two ways. But then we have to think about, like, can we break when k is reached down to 2? So if k was already... So if our number is smaller than k, can we break? Can we just stop looping? That's what I want to think about. So if the size is smaller than k, can I just break out of it and stop the loop? Let's see if we could do that. So if this size is smaller than else, if the count dot size is smaller than k, can I just break out? I want to see if this would optimize it. If you can't, it would give wrong answer. TLE on 2. Okay, so we don't even know if it would break out or not. We just know it's looping too much. Let's see. So we want three numbers, right? We want three numbers. Three distinct numbers. K mod by 3. Let's keep thinking. We have to think really hard. This is a hard problem. This is definitely a hard problem. Let's keep thinking. What if it was like I gotta go soon, actually. But I gotta leave soon. Legit leave soon. But we'll get back to this problem after when I'm done playing basketball. Yeah. Hope you guys like this video. I'll get back to streaming.